All right. Hey, everyone. I'm Jason,
I'm Colin.
and this is our MP2 presentation.
All right, so in terms of the design process, we had many optimization steps going with the most obvious, simple to implement design initially, and then optimizing to get our size down throughout the MP. So a big area of optimization was the ALU, where we had initially implemented every function, all of the 8 functions of the ALU independently, and then put it through an 8-to-1 mux at the end. We realized that the operations could be classified into 4 classes and then decided upon based off select signals rather than just deciding upon based off the opcode, the section of the opcode that decides the ALU operation. And so this allowed us to go from a massive 8-to-1 mux down to a 4-to-1 mux, which saved us a lot of space in the overall design. Okay, so in terms of schematic testing, we had a couple bugs that were mainly due to misunderstanding of the ALU and of the timing of the reg file and qreg. So when it came to the ALU, we just didn't understand the logic unit that we were given and didn't know how to interact with it as a part of our design. And so that just took some, sketching out on pencil and paper to figure out what the actual logic unit was doing, and then integrating it into our design. In terms of the timing with reg file, we didn't understand the part of the document that was explaining how the 2 different clock cycling to the low clock cycling and the high clock cycling were done in order to prevent data from racing through the data path through the reg file. And so after we fixed that, then we were able to eliminate all the errors from our design and move on to layout.
Yeah, so we're going to talk about how we actually split up the work between me and Colin. So when we got to layout, I handled more of the reg bit, reg file, and the latching, while Colin really optimized the mux and the ALU. And then we came together to really lay out the bit slice and data path, as those were very massive parts of our project, and we wanted to make sure that we both had a really good understanding of what was going on. So the original reg bit layout, you can see in this design on the right, it wasn't really optimized that well. The transmission gates were kind of in weird spots, and also there is metal 3 being used in this small design, which would be really bad for later on. We didn't really think like how this design would apply to our final layout. As well as the select A and select B signals were directly vertical with each other, making like those final select pins could be super hard to optimize. So here's our new reg bit layout. As you can see, it shrunk so much. I can go back and forth real quick. The height and the width shrunk. The metal 3 is gone. And like for example, you can see the metal 2 between like the VDD is much smaller now. Like it's not double the size. And so this made for a really compact reg file. So the reg file, this is the original reg file design using like the old reg bit, as well as using the original AND gate that Colin talked about earlier. This was just really poorly optimized. You can see there's so much open space, even between all individual reg bits and the logic at the beginning. So if we take a look at the new optimized reg file, everything looks super compact and flows together super well. The heights are the same of every single sub-design, and there's less logic at the front and the beginning of the chain. Now I can talk about the latch. So the latch was originally constructed from MP1 blocks, which in MP1, our objective was to just try to get it done as fast as possible. And we didn't really care too much about optimizations. So as you can see, like there's very poor spacing, very poor pin placement. And then when we went back and redesigned our MP1 blocks to really worry about space, we had this amazing compact design that really allowed for this latch block to be placed like drag and drop basically anywhere in our design. As well as the pin placements being in really optimal like external locations. This allowed for like really easy chaining between blocks.
So in terms of the original 2-to-1 mux, the design that we decided to go with for our 2-to-1 mux was a 1 inverter and 3 NAND, the simple Boolean equation for a mux. The design worked and it was fairly compact to begin with. However, when integrated into the larger 4-to-1 mux, it wasted a lot of space, as can be seen down here in the bottom right, where we waste a lot of space in metal 3 that could be used for other signals. So by optimizing this, as you can see in the next slide, we were able to get it way shorter. But we did that mainly by removing the body taps, as for the when it was integrated into the larger 4-to-1 mux, the body taps would be included in, we would use 1 of the 2-to-1 muxes with a body tap and then 2 without, so that the N type and P types are still pulled to VDD and ground. However, we saved a lot of space, as can be seen So here's our original 4:1 mux, and you can see down here in the middle section, there's a bunch of wasted space, which made the 4:1 mux extremely tall. And considering that it is the tallest design in our entire overall bit slice, it was a limiting factor in how tall the bit slice could be, and then overall how big the area of our processor could be. So by cutting it down and optimizing the pin placement to make routing signals into the muxes, we were able to save a lot of space and make our routing in the end a lot easier.
Yeah, so we can talk about our bit slice thought process now, as this was a lot of the design work. We didn't really know the correct ordering and how we wanted to lay things out. So what we did was we had like multiple variations of drawing this out on like pen and paper just to really see what signals needed to go where. So our final design ended up with our reg file at the very beginning, and then chaining the R and S muxes after that, followed by the ALU and the mux2 that goes out, and then doing the rest of like the mux logic that leads into the reg file even further after that. This allowed, or at least in our opinion, this was like the most optimal design, as a limited amount of wires that had to go above and below the design. And like Colin just mentioned, the tallest object was the mux4. So really, as long as anything was below that size, it was really easy to like chain together. We also wanted to keep the VDD and ground connections together like as much as possible, as this would lead to like potentially less like net errors where the metal twos could be touching. And then finally for our data path, like we mentioned before, we wanted to keep the pins like directly vertical between bit slices. So like all the mux select pins, those are all directly vertical. The only things that are not vertical are like the function right and left pins that need to go between the different bit slices. And we optimized those to like make sure that they were in like a certain amount of distance and they didn't really cross over vertical metal threes. Other than that, those were our main optimizations. And once we had like all of our individual components, it wasn't really too hard for us to come together and build a bit slice in the data path. So yeah, that's our presentation. If you guys have any questions or like comments about our designs, feel free to just reach out to us. Thanks, guys.
Thanks.